All right, good morning.
Morning.
What I would like to do in the next few lectures is to offer a crash course on C++ program. Because I realize that not everybody in this class has the experience of numerical computation programming in the past. And so it seems it's necessary to talk about programming itself, okay? Even though we try to compress a one semester course on C++ onto just a few lectures, but I think it's doable, okay? Our goal is not to become an expert in C++ programming, but to learn enough so that we can use it for our FEM program, okay? I have prepared a handout. I will post that on the website so you can download that, okay? First, the structure of a C++ program. By the way, most of the material that I use here are from the website cplus.com. Okay? I think it's a very useful website, and the material is clear and also concise, which is important. You can have many thick books on C++, but we don't have time for that. Okay, last lecture we've tried to learn to do a simple program. So let me just refresh your memory that the typical structure of a C++ program is as follows. Very simple. Include. We have the main. The program itself is integer type, and then the function main. And then, like that. And the body of the program is enclosed by a pair of curly brackets. We write it this way just for readability. You don't have to write it like this, okay? And then we can say standard C out. Let's say hello world. Okay, that is a very simple C++ program. And then, because we use this standard output channel or screen stream, we need to put here the derivative, which starts with a pound sign and then include IO stream. Okay, like this. So this whole thing, like purple color here. This is one complete, very simple C++ program. Of course, that is assuming you use the standard C++ compiler. Okay, it accepts that main function. But when we use the Visual Studio, instead of main, there's underscore T something and then main. but it's the same thing, okay? But what you need to focus is here, the body of the program. Just take whatever automatic generated main function and use that. That's just a Microsoft thing, okay? It's not a standard C++ program, but because we use the Microsoft Visual Studio, we just accept that. And remember last time, when we omit that, the compiler will complain. It will not work. Okay? That is because the cout itself, without specifying, is from the standard IOStream namespace, it will not work. So then we can also change that to if you add using namespace std, then we can omit this. So that's the function of the namespace. It will just go to the standard IO stream and find that cout, which is the standard namespace there. And it will save a little bit of writing if you use the cout a lot. In most cases, we will use that a lot, right? A lot of output statements. So put this statement there. And then, as I mentioned, if you do that, and what the output string on the screen, after that, the cursor will stay right behind exclamation sign. If you want the cursor to move to the next line, you can put a \n there. Okay, we're going to talk about that later. So this is a basic structure of a C++ program, and of course, any practical C programs, C++ programs will be much more complicated than that. But the main idea is that here is the body, okay, and you have some derivatives, and then you have a main function. That's the basic structure. All right, next, let's talk about variables and types. There are some, first...
Before you go on, do you need a return 0 at the end of your...
let me see here. I think you don't have to have that, but it's a good program practice. It's a good practice to have that. Okay, if you put return 0, it will then, once the function is completed or executed, the function itself will carry the value of 0. Okay. Because this is a single function, with or without that, there's no practical differences, I don't think. But if you run a program that has many functions and calls, you will definitely return that. Otherwise, the execution point will stop here. Okay. Okay, so that's that. The variables. I'd like to mention that any programming language will reserve certain keywords. Okay, with these keywords, they are reserved by the compiler. You cannot use these keywords as variables. Okay, I'm not going to list a complete list of the keywords, but just some. By C++ compiler, for example, okay, n the keyword AND is actually an operator, a logical operator, a break, and case, class, of course, and if, else, go to, for, float, etc. Okay, in the handout, page 8, you can see the complete list of the keywords. I think it's about, let me say, about 50 keywords that are used. Okay, a very important thing to remember is that C++ is case sensitive, right? Not like Fortran. Fortran is case insensitive. Which means, even though goto is a reserved keyword, but if you write uppercase goto, that is not a reserved keyword. You can use that as a variable if you want. So this is not equal to goto. Okay? And that's a very important thing to remember. All right, next. Fundamental data type. Most program languages requires you or provide a number of data types. The reason that we need to have a data type is when you declare a variable, the compiler has to prepare the computer and assign memory space to it. How much space to provide, that is intimately related to the data type. Okay? So that is because of memory requirement. To understand that, then we need to understand the basic concept of bit. What is bit? Well, bit is the most fundamental one memory space. Okay, so if I draw a square like that, that is 1 bit. It can only store 2 different values, either 0 or 1. And we all know that computer operations are binary. Okay, so bit is the smallest storage space, the memory space. It has 2 values. You can store 2 distinct values. Zero or 1. Right? So that's 1 bit. 1 byte is equal to a bit. So now, if you declare something as 1 byte, the compiler will block out a bit in the memory space for it. So like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1 byte is equal to a bit. Now, because each bit can have 2 distinct values, how many distinct values 1 byte can have? 256, correct? Because 2, each can have 2 values, so it's 2 to the power of 8, which is equal to 256 values, distinct values. So any variable that occupies 1 byte memory space can be assigned a total of 256 distinct values. Okay, once we understand that, now it's good. In the first generation of computer, maybe the second, I don't know whether it's first or second, or a few years ago, most computers are how many bits? 32 bit. And just 2 or 3 years ago, maybe 4 or 5 years ago, and we changed to 64 bit. So if a 32-bit operating system, the memory space is 2 to power 32, it turns out to be about, I think it's 4 gigabytes. Yeah. Okay. And 64-bit will be 264, and that is 4 gigabyte of another 4 gigabyte, which is huge. Okay, that is why any 32-bit operating system, the largest memory chip that can use is just 4 gig. You buy 8 gig, 16 gig, it's useless because it cannot access the rest. Okay. Okay, now type 1, the first type of fundamental data type is character type. Such as the character A, or the special character $sign. Okay? And the character type needs to be enclosed by a pair of single quotes, like this. And its size is 1 byte. So the character type can have a total of 256 distinct values. Okay, this is the first type. The second type is integer. And for integers, there is the complication of signed integer, or signed long integer and signed long integer. So itself carries 3 subtypes. First, signed integer. It has 60 bit or 2 bytes. Right? And the signed long integer doubles the size, which is 32 bits or 4 bytes. And then signed long integer, and that can store up to 64 bits. And then you have the unsigned one. Okay, again, I'm not going to write the full list of that, and it's in the handout. Third type is in floating point. Okay. Types. And the floating point types itself also have several subcategories. Okay. Let me write it here. First one is double. If you declare a variable as double, it Why this is not listed here? Well, at least I know if integer use 2 bytes, the float is at least double that. Okay. That is at least 4 bytes. And there's the long double. And that will be at least 8 bytes. Okay, but I need to, unfortunately the handout I have here, I did not list it, I cannot rely on my memory, but at least that, okay? I'm sorry for that. And then there is the Boolean point, a Boolean type. The Boolean type, it only has 2 values. True or false. Okay. And also in C or C++, true is the equivalent of any numerical value not equal to 0. False is equivalent to any 0 value. Okay? So it's either 0 or not 0. So you need to remember that. And there's also the void type. It means 0 storage space, so no storage. Or you can say it's 0 bit. Okay. There's also the null pointer, and again, pointer is something specific for C or C++. So I just mentioned it here. Okay. There's this type used to specify the pointer. Okay, this is the data type. That is about declaration of variables. All right. Of course, when we write a program, we usually want to use it to perform various kind of calculation. To achieve that, usually we need to define various variables, sometimes are locked. Okay, and these variables are used to store intermediate input data, intermediate calculation result, and maybe the final result also. Okay, therefore, we need to declare a lot of variables. Now, for variables, the rule is that you must use alphabetical letters, numerals, and also underscore. Okay, only these 3 things can be used for a variable. Okay, for example, if I say A, that is a valid or legitimate variable. A1, that's also fine. A underscore B1, that's also fine. And I can also put underscore first, say KSU. Okay. And then KSU3. These are all correct variables. But I cannot put 1A, so that is a illegal variable. I can also not write a dollar sign. That is not allowed. Okay, so only character, alphabetical character, underscore or numbers, and it has to start with either alphabetical or underscore. That's it. And of course, it cannot contain space. Okay. So that's a variable. Now, once you understand the rules for naming variables, now we can declare it. For example, if I write integer a, float my number, then the compiler will know that the variable a can store an integer value is up to 2 bytes. Okay? The float number is 4 bytes. It must be a floating point. Okay? If you assign the number digit, the integer 10 to it, it will assume it's 10.0. It will convert it into a floating point number. Okay? Now, if you can also declare a list of variables together separated by comma, like A, comma, B, comma, C. If you do that, this is just totally equivalent to declare these three separately. Integer A, semicolon, integer B, int C. So these two are completely equivalent. Okay? C or C++ also allows you to declare a variable and initialize it at the same time. Okay? That's different from some of the other languages. Sometimes you have to declare it and then you use assignment to set this value. But in C, C++, you can initialize a variable, initialize it at declaration. Okay. Example will be, if I say integer x equals 0, it will declare x as an integer type variable, at the same time set this value to 0. Okay? And then, this is the old version of C++. I think in recent years, they allows two other type of initialization. Right? One is called constructor. Initialization. Well, you declare an integer, and you put the value you want to initialize the variable to in a pair of parentheses, like that. Okay. So this one and this one, they are totally equivalent. And then there's also a uniform initialization. In which you declare a variable and put it in a pair of curly brackets. That's also allowed. Okay? And then further, the new release of C++ standard also allows you to use another type called auto and declare type. Okay. Auto declare type. Okay. For example, if I declare a variable foo, I initialize this value to 0, and then next I use the keyword that says automatically find the type of the variable and assign it to another variable bar. What this declaration means is this. Okay, I'm going to use the data type of the variable foo and then to declare the variable bar. So bar and foo will both have the type of integer, okay, int. And at the same time, its value is initialized to that. Therefore, that sentence, that statement is totally equivalent to declare integer of, and also initialize it to 0. Oh, no, bar. Okay, and of course, for this simple example, you don't see the advantage or usefulness of that method because you can simply write it like that. But in other program type, it may be convenient because you already declare a variable, you just want to generate or duplicate the same thing. Then you can use this auto instead of go back to the very beginning and looking up what type of that variable is. Okay, so this is convenient in this way. Another way to declare a variable is that you just use the keyword declare type as, so you stripped the type information of a variable and assigned it. If you say declare type of foo, and then use this type, whatever type that variable foo has or is, just the same type. So this is like the same type of that, and declare bar. Okay. And again, this is totally equivalent to integer bar. Okay. Now, and again, of course, for this simple example, you don't see the advantage of using the auto keyword and declare type keyword. Now imagine the situation. You want to test out something, so you declare 20 variables. First, you think integer may suffice. Okay, integer is good enough to finish the calculation. So you declare A up to, let's say A1 up to A20. So, but you are not sure whether you can use integer. Maybe at the end, the calculation is so large that 1 byte of memory cannot store it. Okay, so first you will declare A1 as integer, and all the rest as the same type. So you use auto or declare type to declare A2 up to A20. And during calculation, you find that, oh, the result overflow. Now you can just change the A1 to a double or a long double or float, and then the rest will be changed automatically, right? So in this kind of situation, it will be very useful. Okay. All right, next, let's talk about strings. Strings itself is not a data type. Instead, we call it a class. Or you can also say string is a compound type because it's a combination of a bunch of character type. Okay? So it is a class, a predefined class. The standard C++ already defined it for you, so you don't have to declare that as a user-defined class. Or you can call it a compound type. Okay? Okay, because it's a predefined thing, you will need to use, again, using namespace. Standard. Then inside your program, we can say string my string. Okay, what that statement does is to declare that variable, this is a variable, as the string class or the compound string type. Then after you declare that, now you can assign values to it. Say my string, assign the value of this is a string then you can output cout my string, return 0. All right. These demonstrate the use of the compound string type. Because this is a string type, you can type a string as long as you like and assign it to that, which will be very convenient. If you declare just the character type, you can hold only one character, okay? And you will need to use many characters together to achieve that. But the string type is very useful. You can store sentences, okay? And then output it on the screen. So that is the string compound type. All right, we need to move fast. Next, constant. Of course, all numerical values, they are constant, like integer 10, floating point 2.5, something like that, okay? And sometimes we want to, we can directly type those, but sometimes we want to use a constant variable. I'm sorry, it's not a proper name to say that. We want to use a word to represent a constant. For example, instead of writing 3.1415926 blah 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 as the pi value, if we define that as a constant, it will be very convenient, right? So in this case, we may want to declare the constant and use that, okay, like a constant. That's a keyword. And then we want to use this as double type, and then pi equals 3.1 for 152.926. Okay, that will be the constant. Now, this pi, because I put constant here, it means this value cannot be changed. Sometimes you want that. Maybe when you program a lot of things, there are a lot of variables you forgot. You try to assign new values to pi, and the compiler will not allow it, because this tells the compiler that this value cannot be changed. Sometimes we want that, okay? So that's a constant. And of course, any numerical value, integers, floating point values, they are constant. Character itself, A, B, C, if you put it in like that. Okay. These are also constant. If you write it as A, then you can use that as a variable or string constant, depending on how you declare it. Okay. That's the concept of constant. One caution here, if I write 1776, it always represents its decimal value. So it's 1776, okay? So this is a decimal constant. But C++ also allows you to write a constant in an octal constant or a hexadecimal constant. And if you write a number starting with 0, 1, 1, 3, now that is a octal numerical value, okay? And if you write it with 0 and then x, and then 4b, that is hexadecimal value, okay? The octal value use 8 as the base, and the hexadecimal use 16 as the base, okay? So when you count an octal value, you can go up only up to 7. So 0, 1, 2, 3, 4, 5, 6, 7. When it is 8, you write it as 1, 0, right? The hexadecimal, you go up to 15. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then A, B, C, and then A, B, C, D, E. I think that's it.
There's no 10.
Yeah, there's no 10. It goes to 9.
There's no 9, and then A.
9A, B, C, D.
Oh, okay. Yeah, there's no 10. And 0 up to 9, and then A, B, C, D, E,
F.
F,
And then back to 0.
and then if it's more than F, it becomes 1, 0, right?
Yes. Okay.
Something like that. But it's always kind of mind-boggling to me. I never bother to use that. Okay, unless you want to do some special program. Okay, that's that. And the handout talks about other type of modifier like unsigned, long, or long, okay? So you should do some reading yourself. All right, one more thing about constant. There are some special characters. For displaying purpose or other purpose, we need to write that out. But in the normal case, we cannot use just a visible character to represent it. For example, we want to start a new line, okay? And C++ and also C allows that. All special characters start with a backslash, okay? So if you type these two together represent one special character. So it just means a new line. It will cause something, cause an action to the output, and which may not, it's difficult to represent it without these special characters, okay? All right, and then \r, that means a carriage return. Another useful one is \t, that means one tab space. All right, you can also write something and put a backslash and then b. That means delete. That means backspace, delete one character. Okay. Therefore, if you write a string like A, B, C, D, E, and put B under backslash B, backslash B, backslash B 5 times, okay? The output will be nothing. But if your eye is like a high-speed camera, you can see the output this, and then this disappear, this disappear, this disappear, and okay, it really output it and delete all these. And you can also output a beep like \a, so that's an alert. It just make a sound from the computer. It's like beep, beeping. Okay, so this is a beep. What else? All right, a few other special characters. This. Say you want to output a single quote or double quote, but because single quote and double quote are already used to designate a character type or a string type, right? How do you tell the program, no, I don't want the single type and double type to be used as that function, but itself as just a string or a character? Then you put, again, backslash here. This is the single quote. Or that. Right? Backslash double will be the double quote, which means this. And if you want to literally print out a backslash, you have to do it twice. The first one is a destination that tells the compiler that this is a special character, and the backslash is what I want to output. Okay? So this is a backslash or that. Okay. That's that. Okay, there are some more detailed expression of the constant types, the constants. Again, I think I pick up the highlights here. Then I leave you to do the self-study, some other details, which is not as important as those. The more important topic next is the operator. Okay? Operators. First one is assignment operator. It is the equal sign. For example, x equals 5, like that. And again, last lecture I already mentioned, when you see a statement like this in C++, the correct way to read it is that variable x is assigned the value of 5. Don't say x is equal to 5, because it really does not represent the meaning of x in mathematics. Okay? Then, if you write x equal y, it means assign the value of y to x. Okay, one concept you need to, that is a little bit unique to C++ or C, is that any expression has a value. Okay? For example, this is a variable x which is assigned the value of 5. But this whole thing, x equal from here up to there, is an expression, right? That expression itself carries a value. And of course, for assignment statement, is the value of 5. Therefore, this whole thing, you can view it as another variable. So in a way, an assignment itself can be viewed as a variable. Because of that, it is allowable to write this. Y equals 2 plus parentheses x equals 5. Okay? It makes no sense if you read it in the typical mathematical expression. But it makes sense for C or C++. Why? Because, okay, what is inside a parenthesis will get executed first. So this is a statement. It simply says, okay, assign the value of 5 to the variable memory location x. So x now has a value of 5. But this is an expression. Expression itself has a value which is the value of 5. So whatever inside the parenthesis has a value, and each value, which is 5, get added to this value, which is 2. So it becomes 2 plus 5. Then, of course, is 7. Then assign this value 7 to variable y. At the end, after execution, x will have a value of 5, y will have a value of 7, and the compiler will accept that as a correct statement and make no complaint. Okay? And also, because of that, you can also write something like this. X is equal to y equal to z is equal to 5. Come on. That is again a perfectly legitimate expression in C or C++. What happened is this. For any assignment statement, the right-hand side is carried out first. So this is carried out first. It says, okay, now assign the value of 5 to variable z. But then after this is done, itself is taken as an expression. Expression has a value, which is 5. So that value, that expression value is assigned to the variable y. So y has a value of 5 now. But then, because of that equal sign, that's another expression. It has the value of 5, that value is assigned to x. So at the end, after the execution of that statement, x, y, z, they all have the value of 5. Okay? This is the assignment statement. And then, of course, the arithmetic operators. That includes plus, that is addition, minus, that is subtraction, star, which is multiplication, and forward slash, that is division. And then there's another operator, percentage sign. This is like a modular. Okay? This is addition, subtraction, multiplication, division, modular. I'm sure all of you are very familiar with these. What about this modular? It's used for 2 integers. 7 modular 5. What is the value of that? No, the modular operator will give the remainder of a division of 2 values. So if you divide 7 by 5, the remainder is 2. So it has a value of 2. Okay. Another expression or expression that's special to C or C++ is this compound assignment. Plus, equal, minus, equal, divide, equal, etc. Okay. For example, if I write y plus equal x, that statement is exactly equal to or equivalent to y equals y plus x. Okay. So that plus equal means put that operator, the operator is operated on the variable in front of it, and then add this to the variable on the equal side. And after completing this operation, assign the value to y. Okay? And therefore, y plus equal x is totally equivalent to y equals y plus x. And again, this is, I would like to comment that because C or C++ allow that it can make the program more concise. However, it reduces the readability. A lot of times, I would prefer to write it this way because it's so easy, it's so clear, its meaning, there's no ambiguity. Unless you're very familiar with C or C++, okay, then you write this. Sometimes you really have